Hi everyone, myself Navyatha, working as Assistant Professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today I am going to discuss about the topic schedules in DBMS, and my overview of presentation includes types of non-serial schedule, recoverable, non-recoverable, and in recoverable schedules we have again three types. What are those? Cascading schedule, cascadeless schedule and strict schedule. Let us represent these schedules in a diagrammatic representation that we have already discussed in our previous sessions. So this is what the schedules in DBMS. What is a schedule? Schedule is nothing but a series of transactions that are to be performed in either serializable manner or non-serializable manner. So here the schedules are categorized into two types. What are those? Serial schedules and non-serial schedules. So we have already dealt about serial schedule and non-serial schedule, and in this non-serial schedule we have serializable schedule and non-serializable schedule. So non-serial schedule is nothing but what? Those are nothing but concurrent schedules which are not in a serializable manner, and those concurrent executions also we can make them into serializable. We have those types which are already dealt in our previous sessions. Okay. So this non-serial schedules is categorized into two types, serializable and non-serializable. So what is serializable? Ability to serialize. Ability to serialize. What? The concurrent executions. So to able to serialize those executions, we have two types. Those are nothing but conflict serializable and view serializability. So till here we have already discussed in our previous sessions. Okay. Now in this session I am going to discuss about non-serializable and the types of non-serializable schedules. What are those? Recoverable and non-recoverable, and this non-recoverable is also called as irrecoverable. Okay, and next again this recoverable schedules is again divided into three types: cascading schedule, cascadeless schedule and strict schedule. Let us discuss about recoverable schedule first, which is a part of non-serializable. So what is a recoverable schedule? We can able to recover. If at all we have done any mistake, we can able to recover. Right. So here whatever the transactions that we are performing, in the middle of the transactions, the other transactions may interfere. We have done some of the mistakes or else reading the data before committing the data in the previous transaction. That data is called as dirty read. So these are some of the mistakes that we are going to do, and those mistakes can be recoverable. How we can able to recoverable? That will be dealt in this topic, recoverable schedules. So if in a schedule a transaction performs a dirty read operation from an uncommitted transaction. So what is here dirty read operation? Let us consider this one with an example, simple example. Let us consider here two transactions, T1, T2. Okay. So here I am reading a data item A. I am reading the data item A. So before committing, or else the next transaction is I am updating, writing this data item A. Writing is nothing but for updating. Okay. So before committing this one, transaction T2 may read before committing. Committing means permanently updating the data into a database. That is what the meaning, exact meaning of commit state. So commit state means we are updating the value permanently in the database. So before updating that value permanently in the database, meanwhile, this transaction wants to read the data item before committing. This read is called as what we call as dirty read. This read is called as dirty read. So let us deal this one with an example. For example, A is equal to 100. The database, whatever the item is there, A, the value in that A in the database, let us assume is 100. Okay. Here now I am reading this 100. Next, whatever the operation that I am going to perform here, write operation. What is write? That is nothing but update. So let us, I am updating this one as 150. I am updating this 100 as 150. Before updating, right, before committing this one, that means I am not at all committing, just I am updating in the local buffer. Okay, just I am updating in the local buffer. What is the value in the local buffer? 150. But I have not still yet committed. Meanwhile, transaction T2 wants to read this data. That means what here? Recently updated value 150. So that will be read here. 150. Why? Because recently updated value is 150 here. And later on here, because of some issues, the transaction fails. Then what will happen? Rollback operation will be done. Rollback means whatever the value is there in our previous database, that value will be updated. That means, so because of some issues, power failure or else software issues, this transaction has been failed. So what is the initial value in the database? That will be kept. A is equal to 100. Then what is the operation done here? That is what we call as dirty read. It is not a consistent data, right? Why? Because here I have updated, that has been rollback. Then whatever the operation that I have taken here, which is not there in the database, 150 is not there in the database. So that is the reason we must not read the data before it has been committed. Okay, that read, if at all, without committing, any transaction reads the data, then that read is called as, this read is called as what we call as dirty read. Okay, before committing the data. So a transaction performs a dirty read operation from an uncommitted transaction. Without committing, only the other transaction tries to grab the data. That is what the thing. And it commit operation is delayed till the uncommitted transaction either commits or rollbacks. Then such schedule is known as recoverable schedule. What is recoverable? Recoverable means we can able to recover. If at all we have done the mistakes, later on we can able to recover. Those kind of schedules is called as recoverable schedules. So here the commit operation of transaction that performs the dirty read is delayed, and this ensures that it still has the chance to recover if the uncommitted transaction fails later. So let us discuss this theory part by using a simple example in our next slide. See here, we have two transactions T1, T2, and in transaction 1 we are performing read of A and write of A, read operation and write operation. Meanwhile, without committing here, this T2 has been occurred and it is asking, I want to read the data from transaction T1. It has read the data from transaction, it has already updated also, right? This read is called as what? Dirty read. Why? Because before committing only, in between, before committing only, it has read the data. Okay, that we call as dirty read. And later on, after reading this value, later on it has been committed. Later, here it has been committed. And after committing this transaction, this committed operation has been delayed. Okay, so this is the thing, that if at all we have any dirty reads in our transaction, which may leads to inconsistency of our database. Okay. Next, what is non-recoverable schedule? So if a schedule, till now we have discussed recoverable. Recoverable means able to recover. If at all we have done, here dirty read operation has been done. Inconsistency of database has been occurred, but still we have a chance to recover. Okay. But what is non-recoverable schedule? Non-recoverable schedule means we may not have chance to recover. Okay. Which may leads the database in an inconsistent state, not a consistent state. That is what non-recoverable schedule, which is also called as irrecoverable schedule. So if in a schedule, a transaction performs a dirty read operation from an uncommitted transaction and commits before the transaction from which it has been read the value, then the schedule is called as non-recoverable or irrecoverable schedule. Let us discuss this one with a simple example. So let us consider this transaction T1, which performs two operations, read reading of data item A and writing of data item A. So before committing this one, we have the transaction T2 has been started, which performs a dirty read. Why? Because it has not been committed, but it has read the data, it has update the data also, and it has been committed. It has been committed before the commit operation performed in T1. Let us discuss this one with an example. If at all A is 100, initially A is 100 in a database. Here I have updated the value A as 150 and still not yet committed. Okay. Now, here read of A means here A value is what here? Recently updated value 150. It will read. Okay. Next, it will update as 150 as 200. 150 as 200. Okay. And next it will commit. Commit means what? Here in database the value is updated permanently. The value will be updated permanently. So initial A is equal to 100, but here in this transaction A is equal to 200. Now it will commit as A is equal to 200. Okay. Later on here rollback operation has been done. Rollback means what? The value will be updated to 100. So here A is equal to 200, which is already committed, and here A is equal to 100, which leads to inconsistent data, which is not correct. So by using or by allowing dirty reads, which may lead the database in an inconsistent state. So that is why here we must not able to read or write the transactions before the transactions commits. That is what our intention. So this type of schedules are called as non-recoverable or irrecoverable schedules, which may lead the data in an inconsistent state, which is not in a good state. Next, types of recoverable schedules. What are the types of recoverable schedules? We have three types: cascading schedule, cascadeless schedule, and strict schedule. We have three types. Let us discuss about cascading schedules. The first one. So what is that cascading schedule? If in a schedule, failure of one transaction causes several other transactions to roll back or abort, then such schedule is called as cascading schedule, which leads to the wastage of CPU time, processing time. So that is what cascading schedule. Let us discuss this one with a simple example. So what are here? Let us consider four transactions: T1, T2, T3 and T4. T1 is performing two operations, read of A, write of A. Without committing, T2 has been entered and asked the data item to read. It has read and it has updated. Before committing this, T3 has entered and it has read and it has updated. And before T3 is committed, T4 has entered, interfered, and it wants the data and it has updated. Later on, what happens? T1 has been failed. Then whatever, this one will be aborted, this one will be aborted, and this one will be aborted. Later on, whatever the value is there in the database, that will be there itself. That means here all the time which I have spent, which the transactions has been spent, is of wastage. That leads to wastage of CPU time, processing time. So this is what the cascading schedule. To overcome this one, let us discuss cascadeless, next schedule. To overcome this wastage of time, that means it will not allow until the commit operation has been performed in one transaction. Then only the other transaction wants to read the data. Right. So let us discuss the next schedule, cascadeless schedule. So if in a schedule, a transaction is not allowed to read a data item until the last transaction that has written it and it is committed or aborted, then such schedule is called as cascadeless schedule. Until and unless the first transaction has been committed, write and committed, or else update and committed, then only it will allow the other transaction to read that particular item. Otherwise, it will not allow. Why? Because dirty read may happen, which leads to performance, which leads to degrading the performance of CPU. right? So here what is the thing? Cascadeless schedule allows only committed read operations. Okay. Therefore, it avoids cascading rollbacks and thus saves CPU time. Let us discuss this one with a simple example. See here, we have considered two transactions, T1 and T2. Okay. T1 is reading a data item A, T2 is updating. Sorry, T1 is updating. Here we are performing two operations, read and write in a single transaction T1, and later on commit operation. That means whatever the data has been updated here, that is saved permanently in a database. It has been saved in a database permanently. Commit operation. After commit only, T2 is allowed to read the data to avoid dirty reads. Okay. To avoid the database leads to database in an inconsistent state, we must permit T2 transaction to read the data from T1 after committing the transaction T1. So this is what one of the methods to overcome the dirty reads. Okay, let us consider the second example, whether it is a cascadeless schedule or not. See here, T1 is reading a data item A, T2 is writing a data item A. Okay. And T2 is reading data item B. Is this correct? Yes, it is correct. What I have said, until unless commit operation, the same data item we must not allow the other transaction to read. But here T2 is reading the data item B, which is the other data item. Right, not in T1. So it will accept, it will allow. Later on, the commit operation has been done in T1. That means after write operation, commit has been done. Then only, after commit only, here T2 is reading the data item A. So it is what? It is a cascadeless schedule. It is a cascadeless schedule. Okay. So what is cascadeless schedule here? Which is not allowed to read a data item until the last transaction that has written it is committed or aborted. Okay, that is what cascadeless schedule. So until the last data item is written and committed, then only T2 will read that data item. Okay, that is what cascadeless schedule. Let us consider one more example. Okay, two other examples are there. See here, we have two transactions T1 and T2, and we have the operations, read and write operations, which are performed in T1. Meanwhile, T2 tries to update, not read. T2 tries to update. Okay, that means here T2 tries to write before committing. It will allow. What is the definition here? It is not allowed to read, only read a data item, but it allows to write that particular data. It allows to update. Okay. So then, is it a cascadeless schedule? Yes, it is a cascadeless schedule. Why? Because after committing only, if at all I want to read, I can read the data item. But before committing, I am not reading the data item, right? So that is why it is a cascadeless schedule. But here one problem may occur. That is what? Write-write conflict. That is what? Write-write conflict. Write-write conflict means what here? Here data lost may occur. This will be dealt with a simple example here. Let us consider A is equal to 100 in a database. Okay. Here what I am doing? I am reading the value A. And what I am doing here? Updating. Let us update A is equal to 100 as 150. Write operation. Just I have added one more 50 to that particular data. Now what is the value here? A is equal to 150. Before committing, what here? T2 came in the middle. Okay. Before committing, T2 came in the middle and it wants to update this value. That means to update, adding one more 50. That means here A becomes what? 150 plus 50. That is 200. A becomes 200. Now what is the recent value of A here? 200. Later on T1 committed this one. T1 committed. T1 committed means in T1 transaction, what is the value of A? Recently updated value 150. That has been committed before committing here. That has been committed means permanently saved. So 150 has been saved in database permanently. Then what is here 200? The 200 will be lost, which I have recently updated. That is what here data lost. So even though we are not able to read the data item, it will accept to write the data item before commit. Okay. But after accepting, here also we have one drawback. That is what write update. Write conflict. Write conflict or lost update. We have lost the recently updated value. Okay. So this will be overcome in our next coming up schedule. That is what we called as strict schedule. Okay. Now let us consider this example. This is the last example. So what is this one? Let us consider two transactions T1 and T2. Okay. So here T1 is performing a read operation on A. Okay. Next here T2 meanwhile it is performing read operation on A. Is it correct? Yes, it is correct. Why? Because what is the definition of cascadeless? It will not allow to read. It will not allow to read after write operation, after write and commit. But before write operation only it is reading. So it will allow. Okay. So it will allow. This is also correct. Later on it has been updated. Later on it has been, the value has been updated. This value, whatever it has been updated. Okay. And after write operation, here the data has been again updated. So it will allow. This is what we call as write conflict. Just I have explained in our previous example. It will allow. So this is also a cascadeless schedule. Clear? So what is the drawback of cascadeless schedule? It will not allow to read a data item, right, until unless the update and commit in the previous transaction. Okay. Then what is strict schedule? What is strict schedule here? A transaction is neither allowed to read nor write. So in cascadeless schedule, we can write the data item before committing. Okay, we can update the data item before committing. But here in strict schedule, we may not, neither, it will not allow to read nor write. Okay, data item until the last transaction that has written is committed or aborted. Then such schedule is called as strict schedule. So in other words, strict schedule allows only committed read and write operations. That means here, let us consider two transactions T1 and T2. So after reading, after writing and after committing this one only, it will allow to read that particular data item. Otherwise, it will not allow. After reading, after writing and after committing only, it will allow the second transaction to read that particular item. Strictly, it will not allow to write also. But cascadeless schedule, it will allow to write. Okay. It will just restrict not to read, but it will allow write operation. But here strictly neither read nor write, it will not allow. Okay. So after committing only, the transaction T2 will be available to read that value. Let us consider this one with a simple example. Okay. See, let us consider two transactions T1 and T2, which consists of reading a data item A, and here I am updating the data item A. And later on I am committing here. Then only T2 can able to read this data item and it can update the data item. Okay. So this is what strict schedule. It will neither allows to read nor write before committing. If at all, let us consider this one. T1, T2, R of A, W of A. Without committing, Now I am going to read the data item. It will not allow. Strictly it will not allow. It will reject. Why? Because this transaction has not been. So here the locks will be provided for read lock and write lock on particular data item A. Why? Because still this data is working. Work is under progress. So you must not disturb my data. Strictly it will restrict. So after commit only it will allow T2 to read this particular data item. Okay. So this is what the strict schedule. And let us consider this one more example, whether this one is a strict schedule or not. Let us discuss. Okay. So here we have two transactions T1 and T2. Let us consider two transactions T1 and T2. Here in T1, first initially I am reading the data item A. Okay. Next, what is T2 here? T2 is doing the read operation on data item B, not A. So it will allow. It will allow. Why? Because the data item is different. Okay. See here what I told. If at all the data item is same, then only it will restrict. So R of A, W of A. Here I am doing read and write. But if at all T2 wants to read before commit, it will not allow. But T2 wants to read the data item B, it will definitely allow. Why? Because the data item is different. The same concept is applicable here. Okay. So now, this one which will be accepted. Okay. Now here I am updating the data. Here I am in transaction T1. Later on I am updating. This is first step. Okay. Here I am updating the data. Next, what I am doing here? W of B. I am updating the data value B. Yes, it will also accept. Why? Because here I am not at all touching the data item A in this transaction. Okay. Later on, T1 has been committed. That means after reading and writing, it has been committed. Then only T2 allows to read a particular data item A. After committing, after reading, writing and committing, then only T2 is reading a particular data item A, which has been committed by T1. So, it is a strict schedule. So, what we have discussed in this session, we have discussed non-serializable schedules. So, what are those non-serializable schedules? Can be categorized into recoverable and non-recoverable. Recoverable means which can able to recover. If at all any transaction has been gone through dirty reads, then they can be recoverable. That is called recoverable schedules. What are non-recoverable schedules? Which may not recover, which may leads the database in an inconsistent state. And we have discussed about recoverable schedules, three types. What are those? Cascading schedule, cascadeless schedule and strict schedule. So these are the topics which we have covered, and with this we have completed the schedules concept in DBMS. Thank you.